I told you guys to make up a power rule question. So like 3x squared plus 6x, because I'm making mine aggressively easier than I made the one that I spouted out to you and threw out like 17. I should throw out like 977 x to the million. You guys would have wrote it down. Okay, when we do power rule, when we do the derivative, y prime is take the 2, drop it in front, 3x to the 1, so you drop exponent by 1. And then this would be plus 6, and say we have plus 7 at the back. This would be 6, and then the 7 would completely go away. Do we agree? Now when I say when we drop a number in front, what actual mathematical operation are we doing? Multiplication. So to undo it, we would actually have to do what? Division. And to undo our exponent problem, what would we actually have to do? Addition. We'd add 1 to it. Do we agree? Okay, so let's go back from this now and undo it and see what happens. So if I want just y from this, I would take my 6 and my x. My x would go up by 1 now, and this is where your brains have to remember if you're anti-deriving or deriving. Because when you derive, you take 1 off. When you do the antiderivative, you have to add 1 on. Okay? So this x is going to be to the what? 2, and then I'm going to divide by that number. Because remember, I took that number and I brought it in front and multiplied. So now I'm going to add 1 to it and divide. Nope, we're working backwards. We're going from y prime to y. And then plus 6. Now it doesn't have an x, but if it did have an x, it would be x to the what? 0. X to the 0. So now it's going to be x to the 1, divide by 1. And then this in lies the problem. The 7, the constant, is gone, right? There's no remnants of the constant. The constant is just bye-bye. So what we actually have to do is just put a plus c at the back.
That's not a number.
Okay.
Well, yeah.
You guys need to... So now we have 3x squared plus 6x plus c. Most people will forget to write the c. Don't forget, every single time you do an antiderivative, you have to work back, and you will always have a c. Now, you just put a c and you're done, unless they give you a coordinate on the original. If they give you a coordinate from the original, then you can plug it in for x and y and solve for c. If they don't, you're done. So I didn't give you a coordinate, that's it. Okay? Not too bad. It's also not going to stay like this, but that's okay. But we're going to practice a few like this, okay? So, shh. This is anti-derivatives. All right. The stuff we're all going to talk about for today, for the most part, at the beginning, is going to be power rule. When can we use power rule?
When there's not 2 things multiplied together.
When there's not 2 things multiplied together. Polynomials are really easy for power rules, but there's other things that we use power rules for. What other times can we just take the exponent, drop it in front, and reduce it by 1?
One.
No. You guys are saying polynomials, so you're saying just numbers like 1, 2, 3, 4, 5, but that's not true. What else? Radicals. Who said it? Yes. Radicals are to the power of a half or a cubed or a fourth. You can still drop that in front and then divide it. Yes? So those also work. So we're going to go through a few of these. We're going to go through power rule examples. So you guys are going to try this one. So I want you to find f of x given. I should write find.
Oh, thanks, man.
Guys, the constant is stopping. All right. Take your own advice. All right. F prime of x equals 1/2 x squared plus, minus 2x plus 6. And then b, f prime of x equals 8x to the 9 minus 3x6. After this, we'll also be able to give you like acceleration and ask for distance. Because you can work backwards now, right? I can give you velocity and ask for distance. Acceleration, ask for velocity. But I've only been able to go forward until this one. Try those out. So, f of x. Sometimes they'll say f of x, and then they'll ask you to do the general antiderivative of it. Then they go back from f of x would be the derivative, so then your antiderivative would be capital F. They sometimes do that too. But there's that. Okay, so the first thing I always do is increase the exponent. Just like the other one, we drop the exponent in front. I increase the exponent instead of decreasing it because I know that's what I'm going to have to divide by, right? Dividing by 3 is the same as multiplying by what? A third, correct? So we end up getting that. Minus 2x to the 2, divide by 2, plus 6x to the 1, divide by 1, I'm just proving a point, plus c. So I'm going to get 1/6 x cubed, Gonzo Alfonso, minus x squared plus 6x plus c. Well, I hope you guys all got that. All right. B. We're going to take the 8 x to the 10, divide by 10, minus 3x to the 7, divide by 7, plus 12x to the 4, divide by 4, plus c. Trust me, you're going to get the c's. So then we get 4 over 5, x to the 10, minus 3 over 7, x to the 7, plus 3x4, plus c. Now C, remember how I told you guys in derivatives, when I gave you like two things multiplied, when it was just power rule, you guys would know to FOIL them and then do power rule. But the moment I gave you product rule, I said you might try and do product rule with them, which is way more excessive, right? Same thing here. Right now, because you don't know anything but reverse power rule, I suspect that you would think I should expand this, collect like terms, and then do reverse power rule because it's the only thing she's taught. Okay? Remember that though, when we get past this and we do substitution rule and stuff like that, that expand it and then power rule, reverse power rule. Now, we also only go into very little amounts of integrals. We only anti-differentiate very little amounts of things. We don't do a ton in first year calc or calc with B even. Calc 2 gets into a lot more. Okay? All right. So we have f prime of x equals x, and then remember I told you if you have that, always write it out twice so you don't miss that middle term. So we get 4 minus 4x plus x squared. So we get 4x minus 4x squared plus x cubed. And then we do f prime of x, which equals 4x squared divided by 2 minus 4x cubed divided by 3 plus x to the 4 divided by 4 plus c. And so I get 2x squared minus 4 over 3x cubed plus a quarter x4 plus c. Do you agree?
Yes, man.
Okay, I'm going to give you 3 new ones. They won't be polynomials. They won't be hard. They're just fractions. The harder part is you're in AP math, and a lot of you got hundreds throughout the year. You can add fractions and multiply and divide them. Okay? No one in this class, like the brightest group, even you puke at fractions. No. You like fractions. Fractions are your friend. Change your mindset.
Fractions are dumb.
Be like, please give me more fractions. I love fractions. Change it.
Fractions are stupid.
So, f of x. We're going to get x, add 1, 4.4, divide by 4.4. Minus 2x. How do I add 1 to root 2 minus 1?
If you just get rid of the minus 1.
You just get rid of the minus 1 because you can get root 2. Technically minus 1 plus 1. So she gone. And then we're going to divide by root 2. And so you can just leave it as that. You can go 1 over 4.4. You could turn that to a fraction. It doesn't really matter. And because it's calculus, we don't have to rationalize. Voila. See, I told you.
We guys know that when she's marking our test, she could also forget the plus C if you forget it. If we all.
I told you you're going to forget the plus C. I forget the plus C. It's really easy to forget it. Okay. Quiet, please, paying attention. This one I set you up. What is e to the 2? It's a number. So what would its antiderivative just be? E to the 2 x plus c. E to the 2 is like the number 4, 7, 9, 3. It's a number.
What?
E squared is a number. Okay, so, guys, if I gave you f prime of x was 7, f of x would be 7x plus c. So if I give you e squared, which is the same as 7, it's not the same as 7, it's the same number. It's a numerical value, is what my point is, and you add an x. Same thing if I gave you pi squared or pi cubed or the square root of pi. You'd add an x to it, because it's just a numerical value. Don't fall for e being a variable. It is not. It is a number. If it was a variable, it would be the variable x, which it is not the variable x, because that's the only variable I have in this. All right. This one I have to flip to fractions first. So I do x2 over 3 plus this be x, and then x to the half. What do I do when I have two bases and I'm multiplying? Add them, so I'm going to get x to the 3 halves. And then people are like, I'm done. No, you're not. You literally just rewrote the derivative. Can you not do whatever you do? I just rewrote the derivative. So f of x equals, now when it's fractions, you can divide by that. You can go x, this would be 5/3. But I don't divide by 5/3. I actually, well, I do. I divide by 5/3, which makes me multiply by 3/5.
Somebody forgot to list it.
Plus, and then x to the 3 halves is x to the 5 halves, and then I'm going to get 2 over 5 in front plus c. Okay, next ones I'm going to give you. I'm not teaching you anything. I'm going to give them to you. They are trig. Not teaching. Nope, just pending for yours. Because you can do it. It's literally just backtracking trig. So if I gave you, let's say, sine, I guess I'm teaching you. I guess. If I gave you the derivative with sine x, what would the antiderivative be?
Negative.
Negative. See, I didn't teach you. Thank you. All right.
Let's teach myself in Ohio.
Please. Okay. Is this in a form I can use currently? No, but I did teach you that if you have something over a monomial, you can split them all up into that monomial, over that monomial, not into it. So we have 3t to the 4 over t to the 4 minus t cubed over t to the 4 plus 6t squared over t to the 4. And so I get 3 minus t to the negative 1 plus 6t to the negative 2. And now it's in a form I can use. And I'm going to see if you made a move here.
3 minus 2.
So, f of t equals what? 3t minus t to the
0. D&E.
You're wrong. This is wrong. I want to see if you would catch something.
Divide by 0.
You can't divide by 0, so that's a hint that something is wrong. And then plus 6t to the negative 3. Add, Crystal, add. See, this is where my brain goes in the negatives. It's really where it goes downhill. Minus 1 over negative 1. This I would go t to the 0 divided by 0. Am I allowed to divide by 0? I pushed eraser. Go back into your brain cells. Okay, we're going to go back into our brain cells, and we're going to say, if Mrs. Lepp gave us this as the answer as a derivative, what was it as the question? Huh, ln x. Genius children. Bruh.
Oh my god.
Yeah, bruh. So, let's go back.
You have to convert it to log.
You have to, because you can't divide by 0. So, anytime you go to write dividing by 0, that should be a hint. Be like, wait a second. I can't divide by 0. What must I do? Oh, this is a ln. This was a ln. Every single time. So this would just be ln of absolute value of t, because we don't know exactly what it was. And it needs to be absolute value, because you can't have a negative beside the 1. And we just put plus c. And so we get 3t minus ln absolute value of t minus 6 over t, if you so choose, plus c, or you could leave it as t to the negative 1.
Why does it have to be absolute value?
You can't have a negative beside, and we don't have a restriction on our t, right? You could say t has to be greater than 0, I guess, but is that true? I don't think so. So that t has to be absolute. All right, r of x. What's the derivative, antiderivative of secant x tan x? And what's the derivative of e to the x? And what does the coefficient do? Stays. So it's just 2 e to the x. Okay, this one, f prime of x equals 2 x to the half plus 6 cos x. So f of x equals x to the 3 halves, the 2 in front. Instead of dividing by 3 halves, I'm going to multiply by 2/3. What's the antiderivative of a coefficient just 6? What's the antiderivative of cos?
Sine.
So f of x equals 4 over 3 square root of x cubed plus 6 sine x plus c. Okay, so those are all the ones that if I'm just asking you today to do antiderivatives, that's what you have to do. Yes?
Yes.
All right. Now, those, I didn't give you any coordinates, so it was plus c at the back. Now, sometimes, no, because the antiderivative of cos is sine. Derivative of sine is cos, right? Derivative of sine is positive cos. So the antiderivative of positive cos is negative sine. I mean positive sine, which is what I wrote. Because it goes sine, cos, cosine. You're working backwards. You know, it doesn't like, the antiderivative of c's don't make negatives. It doesn't work the same.
Like emails already on mine.
All right. Now, sometimes we have c's, but once we plug the coordinate in, we actually find out c is 0 and there is no constant, and that's totally fine as well. But we have to be given that. So, this is the last examples we're going to do, or actually be coordinates. So I want you to find f. So same thing, still finding f, right? Nothing's changed. However, now I'm going to give you a coordinate. So let's try f prime of x equals 5x4 minus 3x squared plus 4 and then f of negative 1 equals 2. So that's a coordinate on the original, correct? Not on f prime. It's a coordinate on the original. And if they give me a coordinate, then they can ask for c, with the actual true value. So we still find it the same way. We find f of x like normal. X to the 5, divide by 5, minus 3x to the 3, increase by 1, divide by 3, plus 4x, plus c. And so my f prime of x equals x to the 5, not my f prime, my f of x, sorry guys, so used to writing f prime. My f of x equals x to the 5 minus 3x cubed plus 4x plus c. And remember, whenever you're solving for an unknown, it doesn't matter what science class you're in, what math class you're in, you just literally need to have every other variable filled in. And we know x and y, so we can solve for c, right? This is my x, this is my y. So we have 2 equals negative 1 to the 5 minus 3 times negative 1 cubed plus 4 times negative 1 plus c. So 2 equals negative 1 minus 1 times negative 3 plus 3.
Wait, 3.
What?
3 is going to divide by 3.
It's just an oopsie. Chillax, little vulture.
Hey, we're not judging.
They are judging.
You're totally judging.
We are judging.
Yeah, totally judging.
Okay, so we'll keep the stakes.
Girl, please. Okay. 2 equals cancels. Negative 4 plus c. And c equals what? 6. And then people are like, done. Like, no, you haven't given an equation. You just found out what c is. So we get 5x, or f of x equals x to the 5 minus x cubed plus 4x plus 6. So nothing excessive. You just got to coordinate, now you can find the c. It's nothing like crazy that we're learning here.
That's not great.
Okay. So, it's going to be out of the white textbook, and I'll post the pictures.